Hi everyone! So in today's mini video we're going to be talking about acid-base indicators. Now for a recap of acids and bases, make sure that you check out the electrolytes video and also the pH scale video, because we're not going to really go into a lot of detail about this today because we're really just focusing on what the indicators are. So indicators are chemicals that undergo a color change at a specific pH. So good thing about these is that you can find out the pH of unknown solutions based on the color that they change next to a standard solution. So this is actually extremely useful in chemistry, and it's also really useful for neutralization reactions, because in neutralization reactions, the change of color also indicates if you've reached pH 7 or not. So what we're going to be doing is we're going to be looking at a typical pH indicator chart and looking at types of questions that would be asked based on a pH indicator chart. So here we have a pH indicator chart with a series of indicators. Now, one thing that's really noticeable is that for all indicator charts, you need to have your pH range. So it's always going to be on the top of the chart. And then what you'll have is you'll have a list of indicators. Now, in this one, we have 2, 4, 6, 8, 10 indicators. But most of the time when you're given a test question, you'll either be given 2 or 3 indicators. Now, the good thing about a pH indicator chart is that the different colors tells you what type of substance you have. Now, if we look at our indicator chart, some indicators have more color changes than other. So if we're looking at thymol blue, right, we have a fuchsia, we have orange, we have yellow, we have light green, and we have light blue. So an indicator like thymol blue is actually really useful because it tells us lots of information based on the different color brands. Whereas if we look at something like phenolphthalein down here, they only really have two main colors. Colorless, that ranges from 0 to around 8, and then fuchsia. And then even in the fuchsia range, it's a little bit two-toned. So from 8 to 10, we have light fuchsia, and then from 10 to 14, we have dark fuchsia. So when we're looking at indicators, right, what we really want to look for is indicators that have lots of different color changes. So the more color changes, the more specific our range can be. And we're also looking for where the color changes take place, because different indicators are more useful to figure out if you have an acid, if you have a base, or if you have a neutral solution. So if we're looking at the indicators, thymol blue would actually be a really good indicator for a strong acid, because if we see in our chart, it actually has two different colors at two areas where you have strong acids. So we see that it's fuchsia between 0 and about 1.2. It's fuchsia. And then we see that it's at around 1.2 till about 2.7, it's orange. So this fact right here can really differentiate how strong your acid is just by these two colors. And I mean, thymol blue is actually really useful for denoting a strong and weak base, because we can see right here we have a weak base between 8 and 9, and then we have our strong bases here between 9 and 14. But if we're looking at trying to figure out a strong acid, thymol blue would be the perfect one. Now there's other indicators that are more suited for moderate weak acids, which would be methyl orange, bromophenol blue, and Congo red. And we can see that because if we're looking at methyl orange, so this one right here, we can see that it has two color bands that are in your acid range. We have the pink, which is from 0 to 3, but we have this really good margin right here from 3 to 4 of orange. So if we know that methyl orange is orange between 3 and 4, it actually brings down our range, and we can actually specify our unknown pH. Much easier. Same thing with bromophenol blue. We can see it has that really good range right here. Right here. Again, around 3 to 4. And then with Congo red, we can tell it has 2 bands. So with these ones, we can see that our color changes are more in the moderate to weak area, so around 3 to 5. And we can see that our other brands are just extremely large. So if you were using bromophenol blue to try identify a base, well, it would be not that great because our bases, remember, is from 7.1 to 14, and bromophenol blue is pretty much blue from 4.6 to 14. So that's what, when you're trying to find an unknown solution, you always want to use multiple indicators. And from the reaction of one indicator, you can decide, okay, well, what other indicator am I going to use to narrow down the band? So if we're trying to look for a neutral substance, there's 2 that we can choose from, but bromophenol blue is actually the best one. The reason why is because bromophenol blue, it has 3 colors. It has yellow from 1 to about 6. It has blue from 7.5 to 14. And then it's green for a very, very short band. And it's green from 6 to around 7.5. And why this is really good, because remember, neutral is 7. So when you have bromophenol blue turning green, you know right away that you have a neutral substance. So bromophenol blue is actually used a lot in acid-base neutralization because it gives you a really good color when you've reached neutral, which is again green. And you know if your solution is still yellow, well, you're still in your acid range, and if your solution is blue, then you've overshot it. Phenol red is also useful because it has 3 colors. It has that pale yellow, it has that pink, and then it has that red. But we can tell just from where pH 7 is, so we can tell just from neutral that it's really, really on the cusp of when your phenol red turns from yellow to that pale pinkish rose. So bromophenol blue would be more appropriate. Last but not least, when you're trying to find your unknown solutions for bases, phenolphthalein and thymolphthalein are the best, simply because you have your different colors happening in the basic area. So we can see from phenolphthalein, we have the light pink from around, so for right here, we have light pink from about 8 to 10, and we have our fuchsia from 10 to 14, and the same thing with thymolphthalein. Well, we have this light blue from around 9 to 10.5, and then it goes darker from 10.5 to 14. Now, what we're going to do is we're going to actually look at a typical test question where we'll have an indicator chart, we'll have unknown solutions changing colors, and how we would determine what our unknown solution is. So here we go. Your unknown solution turned yellow with methyl orange and blue with thymolphthalein. What is the pH range? So what you're really looking for in this case is where the colors overlap. Because where the colors overlap is your pH range. So if we're looking at methyl orange, yellow with methyl orange. So methyl orange is again this one right here. So yellow, so it's yellow from around 4.5 to 14. So yellow from 4.5 to 14. So now our next one that we're looking at is thymolphthalein, blue. So it is blue from this right over here, which is 10.5 to 14. So blue from 10.5 to 14. So where do these 2 colors overlap? Well, they overlap at 10.5 to 14. And you see this right here has really narrowed down our pH range, and we know just from this answer right here that we have a strong base. So now what we're going to do is we're going to look at another example, but it's going to be the exact same process. So in this question, we have your unknown solution turn yellow with bromethymol blue and orange with thymol blue. What is the pH range? So again, we're going to be looking at our first one, which is bromethynol blue. So we know that it's yellow between 0 and 3. So yellow between 0 and 3. And now we're looking at thymol blue. Now thymol blue is orange between 1.2 and around 2.8. So orange between 1.2 and 2.8. So the only place where these two numbers overlap is the range where you have thymol blue as orange. So our pH range is 1.2 to 2.8, which is another reason why thymol blue is really useful to find out strong acids, because it has two color changes at a very, very short interval. So I hope this clarified the usefulness of indicators and the type of question that you'll have.